The universe, an infinite sea of mysteries. Every night, we gaze up at the stars, wondering what secrets they hold. For millennia, humanity has sought to decipher the cosmos, peeling back the layers of reality one discovery at a time. Yet, for every answer we find, new questions arise, deeper and more complex than before. From invisible forces shaping the very fabric of space, to unanswered questions about time itself, the universe refuses to reveal all its secrets. Today, we embark on a journey through the 10 greatest unsolved mysteries of the cosmos, puzzles so profound they could redefine everything we think we know. And who knows, maybe you'll be the one to solve them. Imagine standing in a vast, silent void where nothing can be seen or touched, but you feel the presence of something all around you, something that cannot be detected by your senses or by the most advanced tools in our arsenal. This is dark matter, an invisible force existing everywhere yet remaining a profound mystery. It accounts for nearly 27% of the total mass energy content of the universe, and yet despite its dominance we cannot see it, touch it, or directly measure it. It doesn't emit, absorb, or reflect light, so it remains hidden in plain sight. So, how do we know it's there? The answer lies in its gravitational effects. Dark matter doesn't shine like stars, but it has mass, and it exerts a gravitational pull on nearby galaxies and clusters. Without it, galaxies would not be able to hold themselves together. They would tear apart, scattering their stars like grains of sand in the wind. Dark matter is like an unseen scaffolding, invisible yet essential, binding the universe in ways we cannot fully comprehend. But what is it made of? Some scientists believe it might be made of exotic particles, strange, elusive particles that have yet to be discovered. Others think there may be flaws in our understanding of gravity, leading us to question the laws we thought we knew so well. As we gaze deeper into the cosmos, we are faced with a haunting question. Will we ever uncover the true nature of dark matter, or will it remain an eternal shadow, silently shaping the universe from behind the scenes? If dark matter is the invisible glue that holds galaxies together, then dark energy is the invisible force that tears the cosmos apart. For centuries, scientists believed that the universe's expansion would gradually slow due to the pull of gravity. But in 1998, a stunning discovery rocked our understanding of the universe. Not only is the universe still expanding, but it's accelerating at an ever-increasing rate. Some unknown force, is driving this expansion forward, pushing galaxies apart faster and faster. This mysterious force is known as dark energy, and it makes up an astonishing 68% of the cosmos. In essence, it is the dominant force shaping the fate of the universe. But what exactly is dark energy? Is it a fundamental property of space itself, something woven into the very fabric of existence? Or is it the signal of an even deeper, more profound layer of physics that has yet to be discovered? The implications of dark energy are profound. Some theories suggest it could cause the universe to expand forever, its galaxies growing farther and farther apart until they are isolated in an ever-cooler, darkened void. Others speculate that dark energy could lead to a cosmic Big Rip, where the fabric of space itself is torn apart. As we continue to explore this cosmic force, we are left with a haunting question. What will become of the universe in the end? And will dark energy play a key role in its ultimate fate? From the forces that bind and expand the universe, we turn to its very origins. What sparked existence itself? And what came before? Everything we know, everything we are, began with the Big Bang. Around 13.8 billion years ago, our universe was born, expanding from an incredibly hot and dense singularity into the vast cosmos we now see. But what about before the Big Bang? If we look back far enough, what lies beyond? The truth is we don't know. In fact, asking what happened before the Big Bang might be like asking what happened before time itself. The concept of time as we understand it began with the Big Bang. But can there be a time before time? Was there a universe before our own, or is this all part of a never-ending cycle? One popular theory suggests that the cosmos we live in could be part of a never-ending cycle of expansions and collapses, a process called the Big Bounce. In this theory, the universe expands, contracts, and then expands again in a continuous loop. Each cycle could potentially reset the universe, erasing all evidence of what came before. Another idea is that our universe may have emerged from a quantum vacuum, a sea of energy so strange and chaotic that it defies our understanding. Imagine a state of pure potential, where particles and energy fluctuate in a wild, constant dance, eventually coalescing into the universe we now see. If we could somehow peer past the veil of the Big Bang, could we uncover the true nature of reality itself? Or would we simply confront an endless void, a boundary beyond which our minds can no longer comprehend? No matter the answer, one thing is certain. Before the Big Bang, the story of the universe remains an unfathomable mystery, one that may never be fully understood but that continues to fuel our curiosity and wonder about the origins of everything. But how did the universe transform from a singularity to the vast cosmos we see today? The answer lies in a split-second explosion of growth. After the Big Bang, the universe began its journey from a hot, dense state to the vast, complex cosmos we observe today. But there's a mysterious period that stands out, an era of rapid, exponential expansion known as cosmic inflation. This brief, yet incredibly significant event took place in the first few moments of the universe's existence. During this time, the universe expanded faster than the speed of light. Imagine, in the blink of an eye, the cosmos grew by factors beyond comprehension. From the size of a pinhead, the universe stretched to unimaginable vastness, carrying the seeds for galaxies, stars, and everything we see today. But here's the real puzzle. How did this happen? And why did it stop? Some scientists believe that cosmic inflation was driven by a unique form of energy, a kind of inflationary energy that existed only in the earliest moments of the universe. This energy was so powerful, it pushed space itself to expand faster than light, overcoming the gravitational pull of any matter that existed at the time. It's as if the universe had a growth spurt, growing from microscopic to unfathomably large in the blink of an eye. Yet, as quickly as inflation began, it ceased, and the universe entered a more gradual phase of expansion that continues to this day. The question remains, what triggered the end of inflation, and why did the universe settle into its current rate of growth? Some theorists suggest that inflationary energy might still linger in the cosmos, influencing the rate of the universe's expansion in subtle ways. But despite its importance, we still don't fully understand the mechanics behind cosmic inflation. We're left with a universe that is vast, expanding, and full of mysteries. One of the biggest being why and how it expanded so rapidly in the first place. Until we answer that question, we're missing a key piece of the puzzle in our understanding of the cosmos's origins. With the universe's framework in place, we confront a mystery woven into our daily lives, the nature of time itself. Time. It's something we all experience every moment of our lives. It's the ticking of a clock, the movement from past to present to future. But what if everything we think we know about time is just an illusion? Time is one of the most familiar aspects of our existence, yet it remains one of the most mysterious. According to Einstein's theory of relativity, time is not absolute. It stretches and bends depending on gravity and speed. The faster you move or the closer you are to a massive object like a black hole, the slower time passes for you relative to someone far away. Imagine you're in a spaceship traveling near the speed of light. To you, time seems normal, but for someone back on Earth, years could pass in the blink of an eye. What we perceive as time is in fact a malleable fabric, one that can warp and twist depending on the forces at play. But Einstein's theories aren't the whole story. In the microscopic world of quantum mechanics, time takes on an even stranger form. It's possible that time, as we know it, might not even be fundamental at all. Instead, time could be an emergent property, something that arises from deeper, unknown physical laws. In this view, time is less like a flow from one moment to the next and more like a shadow cast by a deeper underlying reality, one that we don't yet fully understand. Some theories even propose that time might not move in a straight line. Could it be that the past, present, and future exist simultaneously, each just a different point in the same larger fabric? If this is true, it could mean that time isn't just a dimension we move through. It might be a landscape we could eventually navigate or even control. So what is the true nature of time? Is it a deep, fundamental part of the universe as real as space itself? Or is it a trick of perception, an illusion hiding a deeper truth? If we could unlock the secrets of time, might we one day gain the ability to manipulate it? Could time travel become a reality, or is it nothing more than a dream? The mystery of time remains one of the greatest challenges of modern physics, and it may hold the key to understanding the very fabric of reality. If time is an illusion, what does that mean for our lives, for the memories we cherish and the futures we dream of? Time's mysteries pale beside the destructive power of the universe's most enigmatic objects. Black holes. Black holes, these cosmic giants, remain some of the most mysterious and enigmatic objects in the universe. Their gravitational pull is so strong that not even light can escape their grasp. In fact, once something crosses the event horizon, it seems to vanish without a trace. But is that really what happens? At the heart of every black hole lies a paradox that has puzzled scientists for decades. According to quantum mechanics, the fundamental laws of physics tell us that information cannot be destroyed. Everything in the universe, whether it's the details of a falling star, the state of an atom, or even the contents of an entire planet, carries with it information. And yet, anything that falls into a black hole seems to disappear, taking all of that information with it. This creates a fundamental contradiction in our understanding of the universe. How can information be lost if the laws of quantum mechanics say it can't? For years, scientists have debated whether information truly vanishes in black holes, or whether there's something more at play, something we don't yet fully understand. Some researchers suggest that the information isn't lost, but instead could be encoded on the surface of the black hole itself. This idea is called the holographic principle. According to this theory, the information about everything that falls into a black hole could be stored at the event horizon, the boundary that marks the point of no return. But the truth is, we still don't know the answer. If information is indeed lost in black holes, it would have profound consequences for the laws of physics. It would mean that one of the most fundamental principles of quantum mechanics, the conservation of information, has been violated. But if the holographic principle is correct, black holes may hold the key to a deeper understanding of the universe, a kind of cosmic memory that we have yet to fully unlock. Until we can resolve this paradox, black holes remain one of the greatest mysteries in the cosmos, a place where the very fabric of reality seems to break down, challenging everything we thought we knew about time, space, and the laws that govern the universe. From the abyss of black holes, we return to a question closer to home. In a universe so vast, are we truly alone? The universe is vast beyond imagination, an endless sea of stars, planets, and galaxies, stretching for billions of light years in every direction. With such a vast expanse and so many planets orbiting their stars, it seems almost impossible that Earth is the only place where life has emerged. In fact, scientists estimate that there could be billions of potentially habitable planets in our galaxy alone. The odds of intelligent civilizations existing somewhere in the cosmos seem overwhelmingly high, and yet, despite decades of searching, we have found no conclusive evidence of extraterrestrial life, no signals, no visitors, no footprints. This paradox, the contradiction between the high probability of extraterrestrial life and the complete lack of evidence, is known as the Fermi paradox, named after the famous physicist Enrico Fermi, who famously asked, "Where is everybody?" If the universe is teeming with intelligent civilizations, then why haven't we made contact? There are many theories. Perhaps advanced civilizations destroy themselves before they can reach out. This is the idea of a great filter, a critical stage in a civilization's development that most never survive. It could be that the rise of intelligent life is rare, or that the technological leap to spacefaring civilizations is so difficult that few ever achieve it. Alternatively, maybe we're simply not looking in the right way or at the right time. Perhaps alien civilizations are using technology or communication methods that we don't yet understand. Or, they may be deliberately avoiding us. Are we just too primitive, too early in our cosmic journey to be noticed by more advanced civilizations? As we send our own signals into the darkness, we're left to wonder, is Earth truly alone in the vast expanse of the universe? Or is there a deeper mystery waiting to be uncovered, hidden in the silence of space? If we're the only ones, does that make us pioneers or survivors? And if we're not alone, why does the cosmos feel so silent? The universe's secrets aren't just hidden in the void. Some lie in plain sight, pulling us toward the unknown. Deep in the vastness of space lies a mysterious force, one so powerful that it is drawing entire galaxies, including our own Milky Way, toward it. This cosmic enigma is known as the Great Attractor. But what is it, and why is it so difficult to understand? The Great Attractor is located roughly 150 million light-years away, in the direction of the Centaurus and Hydra constellations. It's a region of space where the normal rules of gravity and motion seem to be warped, pulling everything in its vicinity toward it. It's as if there's an invisible hand gently tugging on our galaxy, and countless others, toward an unknown destination. But despite this powerful gravitational force, scientists still don't fully understand what the Great Attractor actually is. Some theories suggest that it could be a massive cluster of galaxies, perhaps a supercluster that exerts such a strong pull on the galaxies around it. Others believe that it could be a supermassive black hole, lurking in the depths of space, whose immense gravity is affecting everything nearby. Yet there are still many unanswered questions. Is the Great Attractor a cluster of galaxies, a black hole, or could it be something completely unexpected, something that challenges everything we think we know about the universe? Until we can peer into this cosmic mystery, the Great Attractor will remain one of the universe's most tantalizing unsolved mysteries. Even the oldest light in the universe holds a cryptic message, one that challenges our understanding of reality. Imagine you could look back in time to the earliest moments of the universe, when it was still a hot, dense soup of particles. The cosmic microwave background radiation, or CMB, is the faint glow left over from the Big Bang, and it serves as a snapshot of the universe just 380,000 years after its birth. This radiation is critical for understanding the universe's origins and evolution. Under normal circumstances, this radiation should be evenly spread out, creating a uniform sea of light across the sky. But something strange has been detected in this ancient glow. A bizarre anomaly dubbed the axis of evil appears to defy expectations. Certain regions of the CMB show an unexpected alignment, as if the radiation isn't randomly distributed, but instead, there's a mysterious pattern. The axis seems to cut through the sky, with areas of higher or lower temperature aligned along a specific line. What could explain this unusual alignment? Some scientists argue that it could be a result of random statistical fluctuation, a mere coincidence in the data. But the alignment is so precise, so unnervingly consistent, that it raises deeper questions. Could it be a sign of something fundamental about the universe, perhaps a deeper layer of physics at play? Some theories even suggest that this alignment could be caused by large-scale structures outside of the observable universe, or perhaps an unknown interaction between our universe and another dimension. But until we have a clear explanation, the axis of evil remains one of the greatest cosmic mysteries, challenging our understanding of the universe's earliest moments and the very fabric of space itself. This alignment is like a fingerprint that shouldn't exist, a cosmic clue that the universe's blueprint might be stranger than we imagine. To solve these mysteries, we must bridge the greatest divide in physics, a chasm between the immense and the infinitesimal. Two of the most successful theories in physics, the theory of relativity and quantum mechanics, have revolutionized our understanding of the universe. Yet, they are fundamentally incompatible. Relativity, formulated by Albert Einstein, describes the behavior of massive objects like planets, stars, and black holes, explaining gravity as the curvature of space-time itself. Quantum mechanics, on the other hand, governs the bizarre and unpredictable world of subatomic particles, providing the framework for everything from atoms to fundamental forces. These two theories work brilliantly within their domains: relativity in the large-scale cosmos, and quantum mechanics in the tiny realm of particles. However, when we venture to the extremes, inside black holes or back to the earliest moments of the universe, our current understanding breaks down. The laws of gravity, as described by relativity, are at odds with the quantum rules that govern particles at infinitesimal scales. This incompatibility presents one of the greatest challenges in modern physics. How can we reconcile the forces of the largest and smallest scales? To solve this, Scientists are hunting for a theory of quantum gravity, a unified framework that can describe gravity on the quantum level. Could string theory, which posits that the fundamental building blocks of the universe are tiny vibrating strings, hold the answer? Or could loop quantum gravity, which proposes that space-time itself is made up of discrete loops, offer a better explanation? If we succeed in unifying these theories, it could reshape our understanding of space, time, and reality itself. It may allow us to peer into the heart of black holes, explain the birth of the universe, and even uncover new laws of physics. The universe is full of unsolved mysteries. The answers may lie in the stars, or perhaps inside the laws of physics we have yet to uncover. One thing is certain: our journey has only just begun. As we continue to probe deeper into the cosmos, who knows what we'll discover next? Will we answer these questions, or will they remain as mysteries forever? Only time will tell.